Day 690 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2906, construct product matrix. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a zero-index 2D integer matrix grid of size n by n, we define a zero-index 2D matrix P of size n by n as the product matrix of grid if the following condition is met. Each element P of ij is calculated as the product of all elements in grid except for the element grid ij. This product is then taken modulo 12,345. Return the product matrix of grid. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input grid equals a 2D array of integers or m by n or n by m matrix grid with the first row being 1, 2, and the next row being 3, 4. So let's go ahead and see how they got this output. And so the output is the same 2D array of integers or n by n matrix grid with the first row being 24 and 12 and the second row being 8 and 6. Now let's see how they got this output from this input. And it's quite simple once you get the hang of things, right? So let's go ahead and see. So first P of 0, let's start and just build it out over here, right? Boom. So first what we're going to do is we're going to find P of 0. So we're returning P, which is of size n by n product matrix grid, right? So the output would be P. So right now, P of 0, we want to find P of 0, 0, which would be this cell right here. If this was, let me just build the grid for y'all too as well. Might as well give y'all a better visual representation of what's going on over here. So boom. This is the grid. Let's just clean this up. This is the current grid, and then we're about to build another grid. So let's just do this like this. Boom. We're about to build a grid of the same size, right? So this is the first grid. Right now, we're trying to find what goes in this cell right here. That's P of 0, 0. That's this right here, that 24. So boom, to get that, what we're going to do is get grid of 0, 1 times grid of 1, 0 times grid of 1, 1. So that's going to be 2 times 3 times 4 equals 24. Remember, it says right here, except for the element grid of I. So since we're finding P of 0, 0, I, we're not going to include grid 0, 0 either right here, right? Boom. So that's why we don't use this 1 because it says except for the element grid of I. And right now we're on P00. So for grid 00, we're going to skip this 1. So that's why we do this 2 times this 3 times this 4. That's what this is right here. Boom, that equals 24. So now we know P of 00 is 24. So we can put this 24 right here. Boom. Next, we're going to find P of 01, right? So once again, we're going to do the same thing. We're going to multiply all the elements in this grid except for grid of 0, 1, which would be this 2 right here. So we're going to multiply the 1 times the 3 times the 4. We're going to leave this out because of this rule right here. Boom. So we do grid of 0, 0 times grid of 1, 0 times grid of 1, 1. That's going to be 1, this 1 right here, times this 3, because remember we're skipping 2, so times this 3 times this 4. Boom. When you multiply them all together, that gets 12. We were doing P 0 of 1 of P of 0, 1, so we could put this 12 right here. Boom. Now we're on P1 of 0. We're down to the second row, right? So we're doing the same thing. We're going to multiply all elements of this grid except for P of 1, 0, which in this case is except for this 3. So we're going to do 1 times 2 times 4, right? So Boom, that's what this is. 1 times 2 times 4 equals 8. We could put an 8 right here and P of 1, 0. Boom, now we're going to do P of 1, 1, right? So same thing. We're going to multiply all of these right here. We're going to skip this 4. So 1 times 2 times 3, that gives us 6. We could put a 6 right here. Boom. And now that should match our output. Once we create our 2D array, it would look something like this. Boom, that should match the output. Let's see. Boom, y'all. And that's how we got that. Now, just in case that didn't make sense, let's take a look at example 2. So, hold on, y'all. In example 2, our input grid equals a 2D array of integers or matrix 12,345, 2, and 1. Boom. So, what we could do here, let me see. Boom, let's just construct this grid. Oh, sorry, y'all. Let's construct this grid real quick. Let me copy and paste this over here. Boom, boom. So this grid is just really one column, just like that. So the output is also a 2D array of integers or n by n matrix grid. First row being 2, second row being 0, third row being 0. Boom. So first we're going to get P of 0, 0, which is going to be grid of 0, 1 times grid of 0, 2. So that's going to be this 2 times this 1. Boom. That's where, let's construct our output. Boom. That's where this 2 comes from, right? Comes from these two right here, because remember, we're leaving this one out. Boom. Then we're going to do P of 0, 1, right? So that's going to be equal to this right here times this. It says after we mod it though, boom. So remember, it says right here, this product is then taking modulo 12,000 to the 345 to 12,345. Boom. So since this is 12,345 times 1, that's going to get us 12,345. But once we mod 12,345, remember, this gets us the remainder after division. So once we divide this by itself, there will be no remainder. So that's where the 0 comes from. So we put a 0 right here. Boom. Then same thing down here, I believe, for P of 0, 2, grid 0, 0. So this time, once again, we're doing this, times 2 this time. We're going to skip the 1. Boom, but same thing. That's going to be 24,690, but 24,690 mod this is just going to give us 2, but it's still not going to have a remainder. Remember, this returns a remainder. So even when we divide 12,690 by, 24,690 by 12,345, when we're still not going to have a remainder, right? So the mod will still be 0. So that's where that 0 comes from. Boom. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now let's get into it. Now the first thing we're going to do is we're just going to create a mod constant. So we're just going to say let mod equal 12,345. Boom. Now we need to get the number of rows. So we're going to come underneath this and we're going to say let n equal grid dot count. Boom. Then we're going to get the number of columns. We're going to say let m equal grid square bracket 0 dot count. Boom. Then we're going to get the total number of elements in the grid by saying let k equal n times m. Boom. Now, step 1, we're going to flatten the 2D grid into a 1D array, and this is going to allow us to use the classic product of array except self technique. So, we're going to declare a variable called r, set that equal to an array of integers, put the parentheses to initialize it. Then we're going to say r dot reserve capacity, open up the parentheses, pass in k. Boom. Then we're going to come underneath that and we're going to say for I in 0 dot less than n. We're going to open up the brackets and we're going to say for j in 0 dot less than m. We're going to open up the brackets and we're going to store each value modulo mod to prevent overflow. So we'll say r dot append, open up the parentheses, grid, square bracket I, square bracket j. Come outside of that, we'll say mod. Boom. Now, step 2, we're going to initialize the results array, and res of I will eventually hold the product of all elements except for r of I. So we're going to come underneath this for loop, and we're going to declare a variable called res and set that equal to an array. Open up the parentheses. Sorry, y'all, repeating colon 1 comma count colon k. Boom. Step 3, we're going to build the prefix products, and prefix is going to hold the product of all elements before index I. So we could just declare a variable called prefix, set that equal to 1. Boom. Now we're going to come right here. We're going to say for I in 0 dot less than k. We're going to open up the brackets and we're going to store the product of all elements to the left of I by saying res square bracket I, set that equal to prefix. Boom. Then we'll come underneath that and we're going to update prefix to include the current element. So we'll say prefix equals, open up the parentheses, prefix times r of I, square bracket I. Come outside of that, say mod. Boom. Step 4, we're going to build the suffix products and combine suffix holds the product of all elements after index I. So we'll come underneath this for loop, declare a variable called suffix, set that equal to 1. Boom. And we're going to say for I in stride, open up the parentheses from colon k minus 1 comma through colon 0 comma by colon -1. We're going to multiply the current prefix result with the suffix, and this gives product of all elements except for r of I. Oh, first we got to open up the brackets. Then we say res square bracket I, set that equal to, open up the parentheses, res square bracket I times suffix, come outside of that, say mod. Boom. Then we need to update the suffix to include the current element. By coming underneath that, we'll say suffix equals, open up the parentheses, suffix times r square bracket I, come outside of that, mod. Boom. Now step 5, we're going to convert the 1D result array back into the 2D matrix. So come underneath this for loop, declare a variable called ands, set that equal to an array, open up the parentheses, it's going to be repeating another array, because remember our output is a 2D array, and that's going to be repeating zeros. So repeating colon 0 comma count colon m. Come outside of that, we're going to say comma count colon n. Boom. Come underneath this, we're going to say for index in 0 dot less than k. We'll open up the brackets and we're going to map a 1D index back to the 2D coordinates. So we're going to say let I equal index divided by m, and come underneath this. Sorry, y'all, let me clean that up. Come underneath this, and we'll say let j equal index mod m. Boom. So this is going to be the row. This is going to be the column. Then we're going to come underneath that and we'll say and square bracket I square bracket j, set that equal to res square bracket index. Then all we need to do is come right here and we can say return and y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly. Before we submit it, it's accepted on the first try, y'all. That's what I'm talking about. Let's submit it. Let's see, and look at that, y'all. 24 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, I hope y'all learned something today. Oh, matter of fact, make sure you get one more look at the code. This is the top part. This is the middle. This is the bottom, y'all. And with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.